Welcome back to What You Will Learn. My name is Adam Ashton.
And my name is Adam Jones. Today we're taking you through the best bits of Swipe to Unlock by Agashe, Neel, Mehta, and Parth Detroja. A primer on technology and business strategy. Sorry, fellas, I got that wrong, I think.
You tried. No matter what you do for a living, it's becoming essential to understand technology. Doctors are using AI to diagnose patients. Farmers are using drones to grow better crops. Business people have realized that the world's biggest companies, they used to be built on oil. Now they're all the electric firms. If you think of the biggest companies of the last 30 years, Apple, Amazon, Facebook, Google, Microsoft, that's where the world's headed.
That's it. And in your business, you're probably going to get consumed by some techies throwing around some acronyms and some words that you might not have heard of before, like SaaS or SaaS, APIs, SSL, CDN, AR, VR, the cloud, just to name a few.
It often feels like you need an MBA to understand those TLAs, the three-letter acronyms.
What's a T? Oh, okay. I like it.
It's a bit of a meta.
What's a CDN, Ash? I didn't get that after...
Content Delivery Network,
okay.
I think.
Okay.
Something like that. We'll go with that. But yeah, there's all these things flying around. You probably might feel out of your depth, but it doesn't take much to get a basic understanding.
And you're probably not going to get better teachers than these three blokes. I won't really out their names again, but one of them is a product manager at Google, another is a product manager at Microsoft, and the other one is a product manager at Facebook. So these guys are pretty legit in the tech world, and they know their stuff.
That's right. And the best thing about this book is they gave, somewhat complex and, if you're not in that world, quite strange and difficult topics. They broke it down pretty easy with some simple analogies and some simple stories as well.
So let's take a peek under the hood and some of the technologies, tools and programs about the apps that we use every day, because a lot of them, they're pretty similar when you do take a peek under the hood with the same building blocks.
Yeah, definitely. Netflix and Uber feel pretty different, or Uber and Pokemon Go seem like nothing alike, but they're actually quite well linked. Let's start off with Google. And the first question I ask is, how does Google search work? Whenever you search on Google, the search engine combs through 30 trillion web pages on the internet. They find the top 10 results to your question, and magically 92% of the time you click on a result on the first page.
30 trillion is ridiculous. How many is that? A trillion, 1,000 billion?
1,000 billion, yeah.
So that means each person, individual on Earth, has got 3,000 web pages. I think they
something like
marked
that.
Up an extra zero on the end there potentially. But these lads,
there's a shitload of web pages.
Okay, so it's like if Google's trying to find which one out of 30 trillion, or everyone's got 3,000, every human being, 3,000 lying around the house. It's like finding a penny drop somewhere in New York, but somehow Google just expertly, in just half a second, just figures it out and finds it.
And they said 92% of the time you click on something on the first page. That seems low. I reckon I'm approaching 100% of the time. I'm almost never going to page 2 or beyond. So they do. Google, they've done pretty well to be able to work out, somehow match up what you're looking for, and they magically find it and give it to you.
So Google doesn't knock on every door and just try and find out what you're actually looking for. What it does instead, it stores information about web pages in databases. So it's like this insanely big Excel file where they've got all this wild data. And then they use algorithms to actually read through the databases and figure out, hey, what's the best way to go about this to end up deciding what to show you.
So it all starts with crawling. So Google's algorithm, it starts by building this database of every web page on the internet. They send out what they call a spider to go and crawl over the web pages. And basically what they do, they send the spider to a couple of big web pages, like some of the biggest ones out there. They make a list of all the shit that's on that website, some of the main things. And then what they do is they then go and basically, the spider goes and clicks on all the links on that website to go and find all the next bunch of pages, and they add that to their index. Then they click on all the links on that website, go to the next one, and they basically just do this until they found every possible page there is on the internet.
Yeah, and if you ever launch a website, I think Agashe, our first one, we think, there's all these people visiting our website, and then I think later we realise it's just some of those crawlers, not even real humans. So the index of pages is obviously huge, 100 million gigabytes, and if you have 1 terabyte of external hard drive, you need 100,000 of them. So there's shitloads. So what does this algorithm actually look like?
Obviously, the simplest way to try to find, if someone searches, how do I bake brownies, then they would do a quick search, do a control F of this massive Excel, brownies, and then find, this page has got 15 brownies mentioned. This one's got 12 brownies mentioned. Oh, we'll put the 15 one. That'll pop up as number one.
Which was level 1 Google, right? That's how they started it.
That was, yeah, basically all the, or level 1 search engine for sure. You know, in the 90s, basically that's what it was just keyword density. But, of course, it's pretty easy to game that. Imagine if, say, you're the candy bar company Snickers. Obviously, if someone searches Snickers, they're probably looking for Snickers.com. But, you know, some of the dodgy marketers could game this and just have a random page on their website and just had Snickers 100 times to bump up above Snickers.
Yeah,
so
that's it. So you'd actually have a white background with white text, so you can't see Snickers, but you'd have it a million times, and then you're just going to land Snickers. You probably have every word and just be land everything. It was that easy to game.
That's it.
But they've gotten pretty sophisticated now in changing their algorithms. So they're rolling out minor updates 500 times a year. And it's, if you got some analogy what works best, it's like being who's the most popular at a party. If someone walks in, there's probably a bunch of things that you can see, maybe how they're dressed, the amount of people who's standing around them, and probably the caliber of people standing around them. So if they're rolling in a Lambo with 6 NFL quarterback superstars, for the lack of a better high status individual I can think of, then they're probably going to be ranked high in the party. And similar in Google, if you've got other people web linking to you who have, the New York Times are linking to your book post that you just launched or something like that, you're probably going to rank high on Google, especially as well if there's other high-ranking hyperlinks around the internet.
That's it. And that was really that core innovation of Google. Larry Page and Sergey Brin, that was their PhD thesis in 1998, was this idea of PageRank. That seems recent.
Yes.
I thought it was earlier. But they've done bloody well in just 2 decades to dominate the whole world. But basically, yeah, that's what their thing was. It wasn't just keyword density, which is so easy to game. The main thing was PageRank. What are the big, important websites with high authority scores? Are they linking to you? If they do, that should be ranked higher. There's a few other things in there as well, like how recently it was updated, location. So obviously, if you search football in Australia, you'd probably get the AFL website. If you search football in England, you probably get the EPL website. So location is important. And also they try to blacklist anyone who looks too spammy. Anyone who's dropping Snickers in 300 times on one page is probably out.
Yeah, they get the boot a little bit. Mate, another one that's really interesting is Spotify, which again is a pretty similar one. You can imagine it's being ranked in what it actually suggests to you. But every Monday morning it's pretty scary when you hit Discover Weekly and you listen to it and you're like, shit, they actually know my taste better than I do. And they just deliver you some phenomenal, well thought out music that is just specifically for you.
Yeah, it's
quite
interesting.
amazing.
In that 30 songs, there's probably some you used to listen to when you were a kid. There's probably some you never heard of, but when you hear it, you love it. And it's pretty insane. And so within 6 months of launching in June 2015, this Discover Weekly had been streamed 1.7 billion times. So obviously it's pretty popular. It was working. And if there's 200 million users on Spotify, does that mean there's someone just curating, what's Adam Jones going to listen to this week? I'll pick him a few songs. Or what's Adam Ashton going to listen to? I'll pick him a few songs. Probably not.
Probably not. Well, it definitely feels like that, but it's quite simpler than it sounds. So the way the Discover Weekly algorithm works, it starts by looking at a few bits of information. Firstly, it looks at all the songs you've listened to and liked and added to your library and playlist recently. So it's smart enough to know also if you listen to a song, you skipped it after 30 seconds, probably thought it was shit. Secondly, it looks at all the playlists that other people have made. So, if I'm listening to a bunch of music and Astro's got the same music taste as me or someone else around the world, it sort of matches the two pieces of data up together.
Yeah, that's right. If you've got a playlist and you've put 10 songs on, the Adam Jones special playlist, and then I've got the Adam Ashton special, and 9 of those songs are on mine as well, there's probably a good chance that the 10th one that isn't yet on mine is something I'm going to like, considering we had so much overlap. Obviously, it looks at other things as well, like what types of genres you're interested in. Obviously, the big genres, but also the micro genres. There might be some weird niche things that you're interested in that they can kind of mix and match and put things together and find something different you'd never really thought of but instantly love.
So that's interesting. That's how Netflix movie suggestions, YouTube video suggestions, Facebook's friend suggestions, they use this collaborative filtering where they get everything you do and find someone who's very similar to you and say, if, you got 95% overlap, it's probably a good chance that remaining 5% are going to be big hits for you.
Definitely. The only thing with the Netflix one, you know how it's like, it gives you like a percentage, you know, there's like a 97%. I feel like everything's 95 plus. They're never like, this is a 70% chance.
Yeah, I agree. There's bullshit there. And also the Netflix one, you know, as soon as your partner, like Corey's got my same account, I know straight away when she's ruined the algorithm.
That's right.
All the chick flicky stuff pops in there. So it gets it wrong there. It should know distinctly how different it is. It's like my withers scale. Like one day, I'm weighing whatever it is, 98 or whatever.
Yeah.
Someone else comes in and weighs in 110 when they stand on it. It's smart enough to know the difference. This is obviously someone else.
That's a pretty basic thing.
And that's what Netflix should be doing.
They should. I suppose they've got the different accounts you can have on there, but yeah, you're right. I use the same account as well. And really, I guess the big reason is why the hell did Spotify spend so much time and effort and money in building something like this? And the point really is that it makes it pretty sticky. Once you've built up a bit of a profile, once you've been using Spotify for 6 or 9 or 12 months in Spotify, you've kind of trained it, you've kind of trained the algorithm, and they're giving you the best stuff possible. There's a big switching cost to go over and start afresh on a new streaming platform.
Yeah, there's no way I'm going to Apple Music, probably even if it was free, to be honest. If they charged me for free, I'd still pay for Spotify because of that, the moat they've built there. Now, the last point they got on technology here is another thing where you got Uber, Yelp, Pokemon Go, all similar in this sense, and all technology is able to actually speak with each other. If you think about when you jump into Uber, they haven't created their own maps in there. They're actually borrowing from the other software, Google Maps. And likewise with other technologies, they are able to integrate them into their own apps.
That's right. If you were Uber, and obviously you need obviously a map of pretty much every single street in the world, or at least in the places that you operate, because you need to know where the person is, you need to know what other cars are around, you need to find what's the quickest route. But for Uber to create their own map, it's going to take a bloody long time. They have to drive literally every single street, every single building, and map it out. And for them, it's probably going to be billions of dollars, tens or hundreds of thousands of hours to get this all done. And it's not really going to be worth in the end. And they found a shortcut, and the shortcut is, well, actually someone else has already done that. Google's done that. They've sent their vans around, taken photos of people, sometimes catching people in the act, sometimes catching people doing weird shit on their Google Maps. But at the very least, they've got a pretty accurate and updated view of what the world looks like. And so Uber just says, hey, Google, can we use this info and save ourselves a bit of trouble?
Mm-hmm. And they say yes, of course. And the way they do that is they build this functionality called APIs, so application programming interfaces. So in short, it lets apps talk to each other. So, every little bit of technology, MailChimp, ActiveCampaign, or Stripe, they have these APIs to actually integrate with whatever you're trying to build yourself. And that means you don't have to go out there and just reinvent the wheel. You could borrow elements of other apps to get there.
That's right. If you think of your phone, there's like a camera API that zooms in and focuses and takes photos and saves it to your phone. Obviously, Google Maps, they have this API where other things can then use this Google Maps API rather than building it themselves from scratch. Say the New York subway system, it allows you can track where your trains are and predict when the next train's coming. That's through an API as well. There's all these APIs everywhere that are really just borrowing each other's technology to shortcut the system.
What happens when you type something into your internet browser and you hit enter? It's something we do all day and all the time. And if you asked me before reading this book, I would have no idea. I literally got zilch idea. I know where you were as well, Agashe, if you had no idea.
I was probably close to no idea and close to, in fact, pretty much never even thought about it either.
Yeah. Well, it just feels like it doesn't have, it's not rooted in the real world. It's not like that internet thing is somewhere physical. It's like magically.
It definitely feels like magic, doesn't it? If you don't understand it and you can't explain it, it just feels like there's some magic elf behind the scenes who's just doing everything for you.
Well, it turns out like you've got a home address with a geographically rooted in the real world, your website address is pretty similar, actually. So let's just say if we told everyone listening right now to go to 79 Fake Street, Edithvale, 3193, everyone would converge on the same place. So even if you hadn't been to Australia before, everyone would know how to actually get there.
That's right. You'll end up in the same place. Similarly, if you go to nytimes.com/section/sports, then everybody knows how to get to this exact same spot using that uniform resource locator or the URL. That's probably the bit that you already did know. You knew you type the URL address into the search bar and hit enter. You probably knew about that. What you probably may not have known is that the computer or the internet behind the scenes, they've got no idea what that URL means. And actually what the letter URL that we use is actually linked to a sort of numbers IP address, Internet Protocol address, that the computer knows.
Yeah, so Google, for example, it's like a 216.f58.219, blah, 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 blah. So when you type in Google, it's actually got a number behind it.
I think that would actually work, yeah. We'll do a quick test on the fly. 216.58.219.206.0. Yep, there you go. It takes me to Google. I think it just Google searched for that. Maybe it doesn't. Maybe these guys are talking shit.
Yeah, maybe they're talking.
Maybe we didn't type it in right.
They could, it's like a used car mechanic sort of thing.
But basically what it is, the URL that we use is like pretty much everything's matched up with a number IP address that the internet knows, and then that's why they search for that number rather than for the URL. So then the next question really is like, how does, just because you type the words or that number in and you hit enter, how does it actually get to you?
Yeah, so this is one of the things I would have thought it just goes by magic, but it actually does take a path. So it pretty much does take a similar path as well to as if you were driving to a location. So if we were going from Melbourne to Sydney, the actual internet signal follows the same path just through wires, right?
That's right, and it basically jumps, or it hops is the computer lingo for it, but it hops from basically one intermediate computer to another. So basically the website is broken down into a whole bunch of different packets, and the packets hop from one computer to another, send the signal along, and eventually get to you. Obviously very, very quickly. But yeah, if you're going from Melbourne to Sydney, it probably hops to Seymour, and then it hops to Shepparton, then it hops to Kunumu, and then I don't know what else is along the way, and then it eventually gets to you on the other side.
Which brings us to the next one. What happens when it's in a cloud, though? What about this old cloud? Isn't there just these physical wires redundant because you got a cloud?
Yeah, well, that's right. Don't you think that, if you go back 15, even 10 years really, but you're going to Blockbuster to rent movies, you're buying a physical Photoshop and a CD-ROM, or you're buying Microsoft Office on a disc and installing it onto your computer. Everything's like a physical thing on your computer, whereas now it's just in the cloud, just up in the air, floating around somewhere.
So it really did revolutionize a lot of things. Just to think about Netflix, if you actually to have every movie on your own computer, it'd be a huge database, right? So you're better off actually having it somewhere else. And that's where you actually, what you have gets you. So your utilization of whatever you got is much higher. A bit like a car. Like if you've got, if you just buy your own car and drive it for 1 hour a day, compared to someone who's doing Uber and for 10 or 11 hours a day, there's a higher utilization. You only pay for what you use.
Yeah, exactly. And I suppose the main thing is the cloud, that it sounds like it's something up in the air floating around. It's actually not. It's actually just a whole bunch of other people's computers. There is still those physical wires and stuff. It's just not, as you say, if you want to store every single movie on Netflix, you'd need a whole room, whereas Netflix has got these movies stored sort of all over the world, and when you want to use it, that's when you go and grab it from somebody else's computer.
So simply put, what the cloud really is, it's just someone else's computer. That's all it is. So you just got big data centers where they've got loaded up with specialized cloud computers, and then there's wires from your computer connecting to them. And through those wires, you're just borrowing someone else's wildly big computer temporarily while you use it. So that's what happens when you watch Netflix. You're just actually using that computer somewhere else.
That's right.
Simple.
And it's not just like an employee at Netflix. You're not just using their laptop for a bit, obviously. We're talking massive centers, data centers, rooms full of racks and racks and racks of servers all stacked up with massive cooling systems, because servers, when they're running, they get pretty bloody hot. They've got backup electrical generators so that otherwise if the power goes out and you no longer can watch your Stranger Things season finale or anything like that. And obviously it has a shitload of security as well, because they don't want any... it's important shit. You don't want to lose your movies.
Yeah, they've actually got they've actually got like full hardcore security, like SAS soldiers sort of type stuff hanging out there apparently. And it's changed a lot of things. So software as a service is a new business model where customers buy a subscription, so it's everywhere, and that's through software delivered over the internet. And a lot of the time the apps run on those cloud computers and not on the individual computers themselves.
That's right. So you used to buy Microsoft Word on a CD-ROM and install it onto your computer, so it lives on your computer. But now if you use Google Docs, it's living on the Google servers instead.
But what happens if there's a sudden spike in viewership? So there's a few nuances here. If you are using a cloud computing service and then Netflix launches something like House of Cards in 2015 and then they have a 30% increase in traffic. So it was an issue at one stage in 2008 when Netflix owned their own servers, and you'd actually have to buy the amount of servers to cater for the peak, not the average. So that costs a lot of money. But when they switched to Amazon Web Services, it gave them a lot of benefits. My voice is trailing away.
You really lost it there.
Back on Astro.
Back on. So
just slowly trailed away.
So basically Amazon, obviously you know Amazon for buying shit online, but a massive part of Amazon's business model is also their web services, and we probably should have looked up the stat, but a massive percentage of websites really are run on Amazon web servers because they do have a whole bunch of benefits over using your own. A big one is elasticity. So as you say, when Netflix owned their own servers, they needed the peak, not just the normal. You need to, whereas on AWS, they can kind of cater for those big peaks because they're obviously going to borrow from somebody else at the time who isn't using as much. There's also the scalability. So for Netflix to grow so big, they have to keep building data centers all around the world, whereas now they can just say, hey, Amazon, can you give us a little bit extra? And then another big one is redundancy, in that AWS, they've probably got multiple copies of the same shit all around the world, whereas Netflix, if one building, one data center caught on fire, there goes 300 movies. So probably not quite that simple, but there's some massive benefits of using AWS.
So next time you're watching Netflix, Stranger Things, or whatever it might be, thank the engineers who decided to move them to the cloud, because it did give the benefits of cloud computing.
I think that when I'm watching a show tonight, I'll just say thanks.
You won't, will you?
Netflix engineers.
I don't think I will either. Now, it's a very simple book, this one, isn't it? So if you're someone who just curious about these little things in the world, and I think it does have some real world implications for where everything's going, and you're better off, in one sense, don't you think, going from a 1 out of 10 understanding to maybe 3.5 to 4 out of 10 understanding?
I think they did it really well in terms of it's quite complex stuff and it's very easy to come in. I think even 1 out of 10 is pretty generous. A lot of people are coming in with 0 and someone just comes in and says CDN or API or SaaS or whatever or cloud, and you just chuck along and pretend like you know what you're talking about. Reading a book like this with some simple stories, some simple analogies, some real-world applications to companies that you know and use every single day is a good way to bump that knowledge up, I reckon.